Hi and welcome to all of you for joining this first Novotek Explore session that we have. This is a time where we want to explore industrial tech and relevant concepts. And the first one is sustainability, as you all know. But now I will start to introduce Sean. So when we decided to have Novotek Explore and we wanted to talk about sustainability as a first topic, it was actually Sean was the first that came to mind. Um, because he has over 30 years of experience. He has been in a variety of client management, technology consulting, technology implementation roles, and most importantly, he's been focusing on manufacturing IT. And even more importantly, he's been focusing on customer goals, such as right first time quality, factory to supply chain integration, and the most suitable for this particular webinar, sustainable manufacturing. So I will leave the word directly over to you, Sean.
All right, thanks very much for the introduction. And as I reshare my screen, just so that we've got some visuals as we go along here, I'll also say that probably the other reason I got asked to speak on this particular topic is I grew up in a steel town in the 1970s, and for anybody with a similar experience, we all know what that means. It kind of gives us an inherent understanding that not managed correctly in industry can do a lot of damage to the environment around it. Now, in terms of the topic, a sustainability strategy your CFO would love. Why does this matter? If I'm honest, before we get into the meat and bones of it, I was presenting at the Sustainable Industry Live event in the UK last November, and we had a bunch of senior sustainability people and a few operations people in the room, and we did a few quick polls by show of hand on questions like, how much easily accessible financial support is there to put tools in place to drive continuous improvement as one aspect of your sustainability journey. Not a lot of hands went up, and the more we dug into it, the more we found that there still wasn't necessarily as much faith in the broader executive groups and in the finance groups that people could really use data to make things better in ways that provided rapid payback, sustainable impact, and that would leave room to do more and more. And that was kind of disappointing because I would go out on a limb to say that probably over the last 25 years, from the stories we'll share and the examples we give, you should be able to see that, in fact, all of those things can be true, and the trick is to figure out how to make them true. So without further ado, let's get into the meat and bones of things. For those of you who don't really know Novotek all that well, I'll just give you a little bit of a philosophical grounding in kind of the way that we approach things. And it essentially boils down to trying to make as much use of things that are already in place as possible, whilst bringing a little bit of discipline to the way newer, more supplemental, whether top to bottom or whether more supplementally, when we bring new tools to the table to solve for particular capabilities or requirements. So if we look at the wheel, all we're really trying to communicate here is that whether you're going after quality improvements, whether you're trying to take energy and water out of your products and out of your operation, whether you're trying to get a handle on labor, leveraging factory data in pursuit of a goal typically involves the steps that you see laid out here. And the customers we work with that are most successful are the ones that think about that flow of data right from the point of collection to understanding what kind of contextualization is going to be needed to really make that data useful, both for humans and potentially for other systems, hence the modeling element. And then from there, thinking about where data should live. Do I need to move data from one place to another? Can I leave it in one place and simply reference it for analysis and reporting? How do I present that to humans? Because, with so much talk about AI for all the right reasons, I think we sometimes forget that there's some pretty powerful CPUs between people's ears as well. And that by definition, these are neural networks and they can do some pretty complex relationship analysis if they're simply presented and fed the right info. But again, so we want visualization, we want, engagement of the different stakeholders to be a part of, any major initiative. And then when we think about optimize, that isn't, again, it's not just about, algorithms and AI. Optimize can be about driving the correct work process, error-proofing things so that it's difficult for an operator or a supervisor or a manager to do the wrong thing and create poor ripple effects. So it's with that philosophy in mind that we then looked at the whole question of sustainability, and we realized that there's kind of a good pun opportunity. And if there's one thing that's true of all Brits, and I'm almost one, having lived here 13 years now, we love a good play on words. And so if you think about at a consumer level, we've been taught since we were kids, reduce, reuse, recycle. And fundamentally, if you look at some of the thinking around the circular economy in industry and around sustainable manufacturing or sustainable industrial operations, we've leveraged that same, that same three-word phrase, the same three letters. And so then I got to thinking, well, what does that mean from a data perspective? Well, wherever possible, if you think about that wheel we laid up, and one of our key principles being supplement wherever you can, only deploy new if you have to. One of the big drivers that we live by is not making people spend money twice to create overlapping systems if you can leverage an existing system to get it data or get it functionality and simply trigger it, feed it, use it. And equally, that kind of leads into the notion of reusability. So if I've deployed a SCADA system that's doing a great job running my paper mill or my food packaging line, the data that's in there might have been put in place for the purpose of making the product day by day and minute by minute, but why wouldn't I just try to reuse both the data that's available to inform questions around analyzing optimization opportunities, or equally leverage the existing SCADA as a means of communicating back out an instruction, an alarm, a picture of what could be better and how to get there. And then if we think about, some of the other things that people need to do as part of their, environmental and sustainability goals, whether they're being pushed by a major customer, as some of the retailers now do for the consumer goods supply chains, or whether it's for a government, if we think about things like carbon passporting, or we think about things like, life cycle accounting for carbon, you could argue that a lot of what can go into making those tasks easier for your corporate groups is to repackage data that's already available. And the better a job we do of providing the modeling and the context around that raw machine and that raw process and that raw utility data, the better a job we can do of taking work away from some of those teams delivering on systems that are 2 or 3 steps removed from the shop floor, but whose numbers and the truths within them are 100% dependent on accurate data from the shop floor. So with that in mind, if we apply those principles, even if we set aside, cost of ownership questions. So when I make a promise to a customer, leverage your historian data better. That way you don't need to spend money on a parallel data collection footprint. That's great. That's part of it. But I want to focus on, the kinds of savings opportunities that are a little bit more structural in nature and that could cause a CFO to both understand the attractiveness of a particular continuous improvement driven project, both in terms of the absolute number, equally in terms of the ability to sustain that gain over time, and also often the speed with which the returns can come back in. So I won't talk through every one of these, at least not on this slide. I'll come back to a couple of them, but I wanted to put up these examples to get people thinking about where they may see similar opportunities in their own operation. But equally, we chose these particular examples because each one of them had a financial picture that made them absolute no-brainers for the finance teams in question. We're talking about things that had, cash terms payback in less than 1 year or less than 2 years in many cases, even for some of the bigger, more expensive initiatives. We're talking about things that could be understood to have an ongoing impact, not just be a matter of, capture a one-time gain and then struggle to hold it. And these are things that often, show that what's in the factory has ripple effects out into other aspects of the business, thinking about the logistics-based example here. So each of these has been chosen to get, you folks in the audience and your colleagues thinking about, do I see stories here that make me wonder whether or not some of what we're measuring in our own business in terms of our direct consumption of gas and electricity, our usage of, logistics miles, even things like first pass quality and what that might mean in terms of all of the energy inputs that go into making product that I then decide needs to be reworked or scrapped. We can sow a few of these seeds. I'll come back to some specific examples that get us into more of the methods and how we got to the good result with a particular customer. And again, although we know that a lot of the people that have joined today are coming from, engineering teams, they're coming from IT teams that have become very familiar with their factories. We are seeing more and more people registering who are coming to us with a bit more of a corporate IT title or an enterprise IT title. So for those of you who aren't necessarily 100% familiar with what's commonly in a factory in some form or another, we've talked about reusing and repackaging data that may be easily available. So this is intended to give everybody a chance to be on the same page and understanding what's typically potentially quite easy to tap into, and then what you do with it once you've found the paths to tap into it. So for all of you, manufacturing IT nerds in the audience and all you hardcore engineers, this is pretty straightforward stuff, but it's worth reiterating that almost every modern factory will have an automation layer leveraging, control systems, reasonably intelligent sensors tied into those control systems, probably a SCADA layer, supervisory control and data acquisition, the kinds of stuff that allow for the people closest to the process to run them in a fairly intuitive way. And then in different forms, typically we're seeing an increasing adoption of machine data management platforms, whether that's on premise or in the cloud. It almost doesn't matter these days. The trick is to have it be one that can keep up with the volumes of data that are useful, not just for getting to a scorecard or a KPI, but potentially useful enough to be able to collect data in a granular way, which then makes that data reusable for people to look at continuous improvement processes and procedures. And typically, the more granular, the better for that. And again, I once said in a different setting, and I say it to a lot of our customers, every customer has a production management system of some sort. Now, whether that's a lot of walking around with Excel and paper, or whether it's a full-fledged manufacturing execution system, again, there's usually some mix of IT-ish and non-IT-ish tools. The more IT-ish in some ways, the better, because that's often where we get that final ability to begin to layer things like order context and SKU context into what otherwise might be a flood of raw machine event data and raw data from our utility infrastructure and from the metering that's going into place that directly measures where things like compressed air, natural gas, and electricity are going. So if those are typically there, the trick is to understand how much we need to spend ensuring that there's good structures and model type data around it, different operations, I should say, at different levels of maturity. The more IT centric your shop floor systems have become, the odds are pretty good that you've got a lot of de facto model data available that you can begin to link more granular consumption data to. But even for those firms where there's a bit of manual and a bit of paper still left in the operation, there's often ways that we can fit things in that give you a bridge from the very automated to the less automated in ways that still support some of the principles for continuous improvement. And that's important, because if we can get to that level of context around the data, then what that means is that your whole factory potentially becomes a really nice repository that the corporate teams that are responsible for tackling the questions around life cycle accounting and carbon passporting and I think one of our customers has to repackage their energy usage data into 19 different formats for the different retail stakeholders and regulator regimens that they report into. And the degree to which well-structured plant data can let them automate some of those processes is the degree to which you're not spending those resources on simple grunt work. You're letting clever people go looking for more opportunities to use the data to get better, not just to get the data into a format that regulator XYZ will accept. So let's just take that as a given. There's a decent mishmash of data available. Let's even take as a given that it can be reasonably well contextualized reasonably quickly. Then what? Well, the short answer is where everybody starts is visibility. And the thing that I'd like to emphasize here is that how you achieve that first step is super important, because I can give you these kinds of dashboards off the back of your monthly electrical bills. If you've at least got area level sub-metering or building level sub-metering, if you're in a multi-building campus sort of operation, I can give you enough of an ability to drill down that it'll feel really good and it will support your high level, carbon reporting requirements. But what I can't do off the back of highly aggregated data is put you in a position to ask questions around why there's variance in the numbers and what we might do about it. So visibility matters for a whole bunch of reasons, but we have to think about what visibility means to people in different roles trying to solve for different improvement opportunities. And I actually kind of want to come back to that question of, making sure the humans involved aren't, immediately, ignored in favor of AI tools and machine learning, albeit we do have those up our sleeve. So often what we'll point out to people is if you can bring a bit of that structure to the data and you've got the granularity, you can do a few things that are both useful in their own right by doing nothing more than doing some of that visualization work and allowing the CPU between the ears of clever humans to think about what they're seeing. So we do a fair amount of work on slightly more detailed dashboarding where we can do slicing and dicing, along the lines of plant area or particular production asset. And to the degree to which we're able to establish, a meaningful budget, then we can even begin to cost index the way raw consumption data, can be transformed immediately into an understanding of, am I on track with where I should be? We're going to ignore the question of whether or not those goals are reasonable, whether they were set, based on using data that was too aggregated or not. For now, we're just going to pretend that the goals are reasonable. But again, adding that additional bit of context, can I cost index the consumption of resources into a particular area or asset? If you do nothing more than give a reasonably clever human the ability to look at the information that way, and if they can see variance over time in either the raw consumption or the cost index, that's often enough to get them asking questions like, I wonder why, and I wonder what I can do about it. If I can get even further and get to the point where that cost indexing isn't even just at an area level, but possibly reflecting my ability as a manufacturer to define use of natural gas into a steam jacket around a vessel that heats soup, for example. Well, if I know how much gas should go into a burner over the course of heating up soup to a temperature that cooks the product, keeps it food safe, and gets me to the quality characteristics I want, and if I'm sitting on top of an automation layer that's perfectly capable of telling me what the gas flow rate was into that burner during the production of a given batch, I can actually begin to think about things like energy and processed water and ingredient water as nothing more than just other elements of a bill of material, and I can begin to track them that way too. So why wouldn't I take on board, treating my natural gas into that steam jacket the same way I treat dumping 20 kilograms of diced carrots into that vessel, for cooking the carrot soup? So with that in mind, one of the examples that was up on that earlier screen, tales that a CFO can love, it was just through this kind of view that one of our partners, customers, I'm not going to get into adverts for ourselves or our vendor partners, but those of you who know who we're tied to, you'll probably be able to make a leap. One of our customers in the automotive sector did nothing more than say, there shall be a budget for water and energy consumption at a departmental level. And that led to a bit of a scramble as different departments at least had to put in some basic sub-metering because they wanted to be able to defend themselves against a finance team that was simply going to arbitrarily decide, paint shed, you're responsible for this much of our water bill, welding line, you're responsible for this much of our electricity bill. And in the water department, in the paint shed department in particular, what they discovered was that there was an awful lot of unexpected variation in the amount of water that was going into cleaning out the paint shed at the end of the day, or when they were doing changeovers from a particular type of coating to another. And just that visibility was enough for them to think about what could be driving it, and then to adjust some standard operating procedures, and then to treat the cleaning equipment automation layer as having recipes in much the same way that you effectively have a painting recipe to do a bunch of quarter panels for a sports utility vehicle. And doing nothing more than taking the results of this kind of view and smart humans using their CPUs on it, they found that they could take what ultimately turned into 6 figures a year worth of water cost out of the operation in the paint shed. The actual investment in software and engineering time was significantly less than their first year annual savings. I dare you to find me a CFO that isn't going to sign off on that project if they've got the confidence that, you're going to be able to act on what the data shows you and tame that kind of variance. So we've done the bit where we give the smart humans a chance to do what they can do, but some problems, let's be honest, they're a little bit trickier. We've done some work here in the UK with a food company where looking at solving both a quality and an energy problem meant that there was between 19 and 23 variables to consider. I dare any of you members of the audience to try and solve a 19-dimensional problem using Excel or paper. So there does come a point when you've got to go beyond what the humans can do without help. And equally, there comes a point when just knowing isn't necessarily enough to drive a change in a behavior or a process. So that comes again to the question of, now that visibility is there, if I've done the visibility the right way, the repackaging of that data gets a little bit easier. So we think about, one of the other examples, which I'll come back to in a bit more detail when I talk about, can I use my energy, my water, my compressed, air, my other gases effectively? Can I treat certain things as being like a bill of material, even if they're not part of the product per se? Because if I do that, does that mean that other functions and other systems I have can just work naturally while giving me things that I care about? So short answer, yeah, we'll talk a bit more specifically about that in a minute. Equally, above and beyond what a human can do quickly, can I take some of that work away? Can I make it easy for them to layer in dimensions like what product, what particular batch, what particular, if I've got 22 factories that make the same product, can I take the learnings from, the best example in one particular location and turn those into, an insight that can affect the way the other 21 facilities make that product. So again, we're now thinking about the modeling and the additional work that we can do around the raw data and integrate that with more functionally defined systems that then make it easier to do that kind of comparison. But just as equally, we're talking about how do I put investigative and analysis tools on top of those 22 sites worth of data so that I can begin to extract where we're doing things commonly enough that I should see the same result versus where aren't we, so that I can begin to understand what's the nature of the changes I need to make at a given location. And then we never want to forget the humans for a couple of reasons. Not everything is fully automated, right? So there does come a point where the right answer to keep certain things on track is to just push information to a human. We may have collected enough data, but there's no natural way to push it back out through a SCADA or into a process control layer. Maybe what I'm going to need to do here is to push something to an app on a mobile phone that tells the human, turn the knob to 11 on machine number 22, please. And as silly as that may sound, we do have some customers where, whether it was a simple recipe insight or whether it was, the result of using some of our more advanced machine learning tools, the work might have been complicated. The engineering that went into it might have been quite powerful, but the instructions to the operator can be as simple as turn the knob to 11. So all that, just kind of recapping here, what this tells me is that there's also sort of a way of thinking about this as a human procedure or a maturity curve, right? Take those first insights, go beyond basic visibility, drive behavioral change that's all about non-disruptive. Sorry, let me rephrase this. That's all about doing things that are non-disruptive but are kind of invisible, because I'm going to learn things that don't require me to change behavior yet. Then as I get farther into my work, reusing and repackaging my data, yeah, whether it's from machine learning and AI, whether it's from just clever, thoughtful people doing the analysis, there will come a point when there will be decision support, there will be guided process interventions, there will be, even changes to maintenance regimens. We have one customer that makes sort of the agribusiness end of the food sector, so they've got, oilseed mills, grain mills, and the like. Well, if you're looking at, the motors attached to some of this milling equipment, they're quite sizable. And the fact that motors wear over time means that they're slowly becoming less energy efficient. Now, you can follow manufacturers' recommended maintenance periods, which are all about keeping the motor running, or you can do the analysis that says, maybe they tell me I should do bearing lube and brushing replacement on a certain schedule because that's good from a reliability perspective. But maybe at the same time here, I'm looking at opportunities where, in theory, I can actually recapture some of the motor running at its most efficient level, and the cost savings to do that is worth pursuing. So I'm going to change a maintenance regimen. Well, I need faith from other stakeholders if I'm going to make that kind of change. So if I've done the earlier work from stage one, the odds are good that I'll be able to rally people around that. And likewise, as we get to, taking more advantage of integration and optimization tools, the faith I get from those first two steps on my maturity curve makes it easy to get buy-in from stakeholders to do things that look a little bit more, maybe a little trickier, maybe a little more nerve-wracking to dip into, but with those earlier successes under our belt, then we can proceed with some confidence. And that's really, if I use this example, it was a brewing company that was referenced earlier that had hit their energy savings target 2 years ahead of schedule. And it was because they had followed all of those stages and ultimately got to the point where they could treat energy and other inputs as bill of materials items, and equally they could use the data that was now very well structured in their machine data platform and production management systems to drive a number of other improvements that only leaped out as being needed when they saw that they had unexplained variance in the way they made one beer differently in different facilities, or the way they made the same beer in the same facility differently at different times. So with all that said, these are the steps that we can take, and ultimately that does put us in a position where the newest and latest and greatest technologies coming from the software vendors and the edge technology processing vendors can be really applied after the thorniest of questions. So there is a process that we teach people about how you can learn from the data you've got, how you can extract the insight into how a machine learning tool or a human can then leverage what you've learned from your big data explorations, and then how you can deploy that as a fairly simple set of instructions or as an algorithmically driven real-time analytic that can interact with a human and or the process layer. So all that's out there, but we generally are coaching our customers to understand that if you try to work backwards from what a machine learning tool or an AI tool can give you, you're probably going to find that some of that more foundational work, as well as the bringing the people along for the ride, might be compromised. So we very much recommend doing things in a particular way, because you're then likely to get the organizational buy-in and be able to sustain the changes and the gains that you make. And this final example I've got here is all about that. So the main thing that I put this example up for is for this little thing that looks like a portal screen. This is operators beside, a food production operation able to see the cost indexed impact of allowing a process to drift out of control versus following guidance given to them by a machine learning tool and its runtime analytic, minute by minute, hour by hour, day by day. And their particular story is that they reduced their quality complaints, they improved their quality to the point where it was repeatably falling into a Six Sigma kind of, performance reliability. And equally, they took 3% of the energy cost out of some of their most energy intensive processes. So that kind of represents a good end state. Now, we got a really great audience here today. And Amanda and I were looking at who signed up from where. I was pleased to see we had people from all across Novotek's home territory across Northern Europe. Equally, we had people from a little farther afield because we do business with folks that are headquartered in our region, or they work with IT consultancies and other important people in their ecosystem that happen to be based in the UK. So I happen to be a Canadian guy living in the UK, but I just want to emphasize that, as a company with reach across Northern Europe, whether you're joining from Finland, Sweden, Switzerland, if you need a hand getting oriented to who the Novotek people are in your area that can help you, learn a bit more about the kinds of things that we've just shared, reach out to myself. I'll share my contact info on the later screen. For now, I'll turn over to Amanda to see what questions may have accumulated in the queue.
Thank you so much. And thank you so much, Sean. Big applause to you. We got 2 questions so far. So the first would be, why do this if I could just deploy renewable energy assets or CHP systems? Am I saying that correctly?
Yeah. Combined heat and power, again, for people who aren't, necessarily native English speakers. And I think the short answer is because it's incremental, and equally, if we look at a lot of the renewable energy assets that people are deploying, the simple question is, why potentially run a new good asset in ways that aren't as smart as they could be? And depending on exactly what that asset is, so if we think about a combined heat and power system in our food sector customers, we see an increasing number of cases where they will put in an anaerobic digestion system, reprocess their own wastewater and food waste streams, generate some gas, and then they'll look to use that. And the short answer is, if I treat that AD system and the CHP as if they're monolithic, as if you just turn them on and they go, the same way I drive my car, you're potentially missing an opportunity to get the most kilowatt hours out of that asset. And that may mean that you're not coming as far off the grid as you otherwise could. So there could be cost implications. There could still be carbon implications. There could be best use of your own waste stream implications. And that may matter depending on who the stakeholders are that care about your Scope 1, Scope 2, and Scope 3 emissions. So I guess I would leave it there for the sake of time, but certainly if anybody wanted to pick up that as a line of conversation, reach out to me, please.
We'll have one more where it says, where have you seen the most payback? So where can you start for the best return of investment?
Yeah. So there's so many ways to answer that. I'm going to leave people with 3 thoughts. In general, if you can drive a yield improvement in your process, and it doesn't really matter whether you're using laser cutters to take slices out of a coil of steel, whether you're baking bread, really doesn't matter what the industrial process is. If you've got an ability to measure baseline energy into that process, that's great. That's quite useful. But one of the things I like about doing the modeling work to put a bit of order and skew context around it is yield savings outweigh typically pure tuning opportunities but you won't know what you can do safely to tune your energy and your water and other inputs unless you're also measuring whether it's having a negative effect on quality. So if you think about that final example, that architecture, and then I showed that one little portal screen cap, which I kept small because I didn't want to run the risk of sharing proprietary info, but for them, it was all about we need to take energy out, but we absolutely can't compromise quality because we're a consumer-facing brand. If somebody opens up my package of stuff and it's too dry, or it doesn't mix nicely, or it doesn't do what it's supposed to do, that is an even bigger problem for me than energy. So I'd say focus on yield and energy together, because if you can save on waste or rework, you're probably going to outweigh pure tuning. But if you do that, you're going to be in a position to solve for both. And that means you're going to get the most of all possible. You're going to get the best of both of those kinds of changes.